Let's go over the different phases and the hormones involved in digestion. There are three main phases of digestion. You have the cephalic phase. Cephalic is referring to your head. Just the smell, the sight, or the thought of food will already start to activate your neural centers and begin getting your mouth and your stomach ready for food that is hopefully about to enter it. So you'll find that if you think too much about a juicy cheeseburger or a delicious salad that's full of fruit, you'll start salivation. You'll begin the digestive processes and secreting some of those juices, even just the thought of it. Next, we have the gastric phase, and this is where food will actually enter your stomach. You've got different neural mechanisms and hormonal mechanisms that help to promote secretions in the stomach and also motility. You'll start those mixing waves. Finally, in the intestinal phase, this is when food actually enters the small intestine and it slows the exit of chyme from the stomach. You don't want to overwhelm your small intestine, so you just enter a little bit of chyme at a time into the small intestine. And this is going to stimulate the flow of bile and pancreatic juice because those are secretions that will help you digest that chyme when you enter the small intestine. So here on the left, we have an image of what's happening in the cephalic phase. As you think about or look at food, you have vagus nerve stimulation. The vagus nerve carries the vast majority of your parasympathetic output. That's your rest and digest branch of your autonomic nervous system. And so vagus nerve will help to stimulate the secretions in your stomach. This middle picture is looking at the gastric phase. And this is what's happening when you actually have food in your stomach. So again, we have stimulation from the vagus nerve. Parasympathetic nervous system is very active during this phase. You are promoting secretion of gastrin, which is a hormone, and also histamine, which promotes the flow of gastric juice. And so you're continuing to secrete acid and enzymes at this point. Finally, as food begins to enter the duodenum, you have feedback heading through the vagus nerve back to your autonomic brain centers, and you have sympathetic stimulation that will begin to inhibit the stomach. You want to begin turning the stomach off and turning the small intestine on because you're about done with this chyme that's in the stomach. And so you have gastrin from the intestine that will promote the stomach a little bit, but mainly you're going to get some secretin and CCK, which stands for cholecystokinin. These hormones will continue to turn the stomach off and begin to turn on the small intestine and promote juices that will help to digest the chyme that has entered the small intestine. Here are some different specific hormones that you'll need to know. And we've talked about a couple of these briefly. So here's gastrin. It's secreted by the enteroendocrine cells of the stomach, specifically those G cells. And it's secreted if you have food that enters the stomach, especially if you have some partially digested proteins or if there's acetylcholine being released. It targets the stomach and the large and small intestine. It helps to increase hydrochloric acid secretion. It stimulates the contraction of intestinal muscle. You're getting that intestine ready for receiving chyme. And it also relaxes the ileocecal valve. And so kind of what's happening here is you have a meal that's entered the stomach, and that meal ultimately is going to enter the small intestine and then the large intestine. If you have any leftover food, if you have a previous meal that's still sitting in the small or large intestine, you want to move that along and make space for this new meal that you're digesting. And so what you may notice in some people is as you consume a meal and as it enters your stomach, that may stimulate your urge to use the restroom. And so you're actually making more room in your intestine for this new meal. So that's the job of gastrin. Histamine is secreted in the stomach when you have food in it, and it tells your parietal cells to release hydrochloric acid. And so you're releasing more of that acid, which helps to promote digestion in the stomach. So I think of gastrin and histamine kind of as turning on the stomach. Secretin and cholecystokinin, I kind of think of those as turning off the stomach and turning on the small intestine. You'll notice that the site of production is the duodenum compared to the stomach, and you'll notice that the stimulus for the production is acidic chyme. So when you have those enzymes, including some hydrochloric acid, that enters the duodenum, that is going to prompt the secretion of secretin. Also, if you've got fatty chyme and partially digested proteins that enter the duodenum, that is the stimulus for cholecystokinin to be produced. So what secretin does, it inhibits gastric gland secretion, so you're decreasing the gastric juice secretions, and it increases pancreatic juice secretins. And as you have more pancreatic juice being released, it stimulates more CCK, cholecystokinins, actions. It also increases the bile output. So you have all of these things that you need for digestion to occur in the small intestine, and you start to slow down digestion in the stomach. CCK is similar. It's going to inhibit the stomach secretions. It potentiates secretin's action, so it's working together with secretin and potentiates its actions on those organs. It increases pancreatic juice output, stimulates the gallbladder so you get some more bile that's released, and it releases the hepatopancreatic ampulla and sphincter. Remember that you have a bile duct system that connects the liver and the gallbladder along with the pancreatic duct, and it has all of those ducts being sent to the small intestine, to the duodenum. And the place where they come together is the hepatopancreatic ampulla. And so you want to make sure that that ampulla is nice and open, the sphincter is open, so that the bile and the pancreatic juice are able to get into the duodenum. Finally, we have GIP, glucose-dependent insulinotropic peptide. This is also released in the duodenal mucosa. It's released when you have fatty chyme that enters the duodenum. This is secreted by pancreatic beta cells. Remember, those beta cells in the pancreas are responsible for secreting insulin, and this is going to stimulate insulin release. Why do you need insulin release? Well, you're absorbing a meal, or you're about to absorb a meal in the small intestine. You are about to get an influx of glucose into your blood as you absorb that meal. So you're going to need insulin to help move that glucose into your target cells that need it to produce ATP, and also to move the excess to the liver for storage. So if you're actively digesting a meal, you want to make sure that you have insulin that's available to help you take care of all of that glucose that's about to hit your blood.